Okay, we're gonna do chapter 27, chapter 28. Sorry, we're gonna do chapter 28, and I have to assure you that this, the code in this chapter is beyond what you might expect to do as a beginning coder. But you can't really get into game development unless you just kind of trust what the code is allowing you to do and kind of pick it apart piece by piece. And that's what I appreciate about Jeremy Gibson Bond's approach to things in this book. So he's giving you a prototype. I mean, he's basically just handing it to you. But while he's doing that, he's also allowing you to see exactly how things are constructed from start to finish. And so, before we embark on coding and all the complexity and all of the things that we might get into within this space, I want you to understand that we're doing a very simple prototype, and we're going to need to code a few things to get it to work. And it's not HTML and it's not CSS. It's object oriented programming, where we're going to attach behaviors and behavioral scripts to different types of objects within our games. So it's a different way of thinking about things, and I want to be able to meet you where you are in certain ways with this type of programming. And my favorite thing to do is to just get into it, and then if you have questions, you ask them. Everybody has questions. I I discover something new every single time I open up a code editor or browser. And that's part of the excitement of doing this stuff. So, without further ado, let's get straight to it. We're gonna look at the portion of the book that starts with the flowchart of the apple tree. And this is the flowchart that we looked at in the first video briefly. This is the one that we're going to add some randomness to how the tree is moving back and forth. It's super exciting. Once we get into it, you got to type some code in here first. So what I'm going to end up doing is I'm going to show you the code that I'm going to enter. And then I'm going to hit pause on my recording, and then magically all the code's going to be entered, right? And so I'm going to tell you to like hit pause, and then type all the stuff in, and then we'll get to it. All right, so let's get to the prototype here. So the very first thing we want to do, obviously, we want to be coding the apple. Which one do I want to do? I want to do the apple tree first. So, so we're going to open the apple tree class in Mono Develop, and actually in Visual Studio. So anytime you see Mono Develop in here, you're going to make the mental substitution of Visual Studio. So, so we're going to start with the apple tree, right? So I'm going to double click on the apple tree. It's going to open up Visual Studio for me, and so now we have our code. And what you'll notice up here is it shows you that we're looking at appletree.cs, right? And we're also calling in the systems collections and system collections generic and using Unity engine. And this allows us to have the main setup for our work. Okay. And then back over in our tutorial, we're going to take a look at what we're going to be doing. We're going to move at a certain speed every frame. We're going to change directions upon hitting the edge of the play area, change directions based on random chance, and drop an apple every second. All right. So so this is the setup. The first three lines are given to us. And then public class apple tree mono behavior, we'll see in Visual Studio that shows up right here. And then we have our voids and our starts, and then we have a couple of variables that we're going to add in here as well. So you notice that void and update, void start and void update are here. So they're going to correspond right in this space as well. All right. And I'm going to start from here first. It actually helps me when I'm looking at code to kind of give it a once over and then just to get a sense for what's happening in our active spots, right? So when we start the program, we're going to be dropping apples every second. Then when we update the program, we're going to have basic movement and changing direction happening whenever the frames update. Okay. So I'm going to go back over to Visual Studio, and I'm going to type in those comments here so I can keep track of things. And the first comment is certainly dropping apples every second. Right? Let's really have, or was it 0.5 seconds? I can't remember exactly. I thought it was 0.5 seconds, but then in the text he said seconds. So we'll see. And then this is, tree movement and changing direction. And so so that's where the starts and the updates are going to be called. Now, but here, after line 6, inside this public class, this is where the rest of that code is going to go. So I'm going to open up a whole bunch of space here. And I want you to see this, that I'm just like opening up some space. But we want to treat all of these things just like with any other code. We want to treat these as containers, right? So void start, that's going to be a function. Everything that happens in here is going to be inside this function. You know the saying, everything that happens in Vegas stays in Vegas. Think of these as Vegas, right? Anything that happens here is going to happen in this function. Once we leave Vegas, then Vegas is over. We're on to other things, right? So so I'm going to go back up here, and let's take a look at each of these items. So the first thing I'm not copying and pasting these things necessarily. I really don't like copying and pasting from here, and this is why I asked you to get a text editor of some sort so you can have a place to copy and paste code from a book setting into something that would be more machine readable. So so what I intend to do here is, instead of having these up side by side, what I'm going to do is move this over so I can have both things on the screen, right? And then I'll just type some stuff in here. So we have this little thing that says header, right? And we're going to say set in inspector. And we'll see how that works in just a second. And then we have the prefab for instantiating apples. I'm not going to type in all of the comments for now, but we're going to do public game object, and we're going to call this apple prefab. Okay. We're going to do a public floats speed, and that's going to be equal to 1f. The f here is indicating that it's a floating point value, which means that it's going to be a decimal based value, right? So then we have a public, whoops, let me type public float, left and right edge equals 10f, right? And then we're going to do public float. Chance, I said I was going to pause, and I'm not going to. Change directions equals, let me just make sure that I'm doing this right, is 0.1f. And then the last one is going to be seconds between apple drops. So public float, seconds between apple drops equals, I think I messed something up. Okay, 1f. He said half a second though, which is kind of odd to me. So 0.1f. Right? So what I'm going to do here is just add some space in here so that we have this looking kind of neat and readable. And this is what our class is going to look like. So so let's just pause for just a second and take a look at this. Right? We have a game object that's a variable. We have a floating point variable. Oh, actually, four floating point variables. We have the apple prefab, and then we have the speed, left and right edge, chance to change directions, and seconds between apple drops. What's going to happen in Unity is that these are going to be variables that we can change during gameplay. So I'll show you how that works in just a second, but for now, I'm going to close this. I'm happy with how this looks. I'm also going to change or close this little thing. And then the step that we need to do is we need to actually attach the apple tree script to the apple tree game object. So I'm going to go back into Unity. And what I have here is this apple tree script. I'm going to drag it over into the apple tree game object. So notice that where my mouse is, right up there, I'm going to just drag it on there. Make sure I'm attaching it to the shape and not to the trunk or the leaves underneath it. And then when I do so, if I click on apple tree, you'll see that the apple tree script is over here. Now check this out, y'all. This is awesome. So all of those variables that I just added in, those variables are going to show up here. We've got the game object, the apple prefab. We have the speed. We have left and right edge, and the chance to change is 0.1, and the seconds between apples is customizable here as well. We set up defaults, but we can change these variables at any time. I think that's really exciting and a key idea that I need you to understand here too. So I'm going to hit save. The reason why we saw that is that we went into our code, we typed in a few things, and we were able to see those changes. And so, so here we are. Now, what we're going to do is let's hit play. You know what? Why not? Let's hit play. Okay. And nothing's happening. We didn't actually set any motion in place yet, but that's okay. So what we're going to do is we're going to set in the inspector the apple prefab. We're going to link up the apples to this in just a second. So so he suggests in step 3, try moving the apple tree around the scene by adjusting the X and Y coordinates to find a good height for the apple tree and a good limit for left and right movement. All right. So so he's gonna give us some suggestions here. We're gonna set the position of the apple tree here to 0 and 12. So it's a little bit higher on the screen. If it's down too low, that's no good. If it's up too high, we can have it be 13. It's really close to the top. So 12 is looking pretty good in our viewport there. And then our left and right edge is looking to be 10. So we can double check to see where the position of that is. So that's on the x-axis. So if I go 10, that's going to be our left edge. And if we go negative 10, that's going to be, well, that's going to be our left edge, and our right edge is going to be 10. So up here is where I'm typing, up in this position area. And whatever variables that we set here, you know, or whatever position items we're going to set here, we're just kind of testing to see what's going to work for our left and right edges. If we decided that we wanted this to go to 20, that's going to go very far across the screen. And then negative 20 is going to take us all the way back. So I'm going to leave this set at 0 for now. And let's leave the left and right edge set at 10 for now as well. Okay. So now, oh, I'm sorry, to 20 is where we wanted to go with that. So we're going to set this to 20. Okay. So we save that. What's interesting too is if we go back to our script, the variable doesn't change in Visual Studio, right? So if I go into the apple tree script, open that guy up, that 10F is still going to be there as our default, right? But in here, whenever we click on apple tree, we're setting it dynamically over here to 20, right? So so once we're in the game, we get to do things however we want to. He has a note about getting help and using help scripting reference and that sort of thing. I am not going to get you into that, but I will show you that like the help system is extensive. There's tons of information on everything, and no human is expected to understand this on first read. It's just the fact of the matter. So if you get stuck with anything, you need some additional help, please use me as a resource to try and help you out if you get into a bind. All right, so now what we're going to do here is we're going to have in the update section of the code, we're going to transform the position of the tree as we're moving forward. So this is going to start to feel like magic, right? First things first. You see this triple dot here? That means that all of the code that we already typed in stays there. We're not changing anything else. We're keeping that code in place. All right. Now, what I want to do here is go back into my, I should have kept the code open, but I go back into my apple tree code, open that guy up, and we leave all this stuff in here. We leave start alone. We come down to update, and this is where we're going to put in our motion code. All right. And it's 3 lines of code. It's going to make a huge difference here. So we're going to use, first thing is a vector 3, which means that it's a vector. It moves in a direction. A vector moves things. All right. And the vector is going to be vector 3. So that means it's going to have an X, a Y, and a Z value because it's moving in 3D space. All right. So we're going to do a vector 3. And we're going to call that POS, which is going to stand for us as position. And we're going to look for the value of transform.position. Now, what this is doing, it's going to get the variable of saying, hey, you know, the position that this thing was in before, where is it now? So it's gonna look for where the apple tree is. It's attached to the apple tree. So the apple tree is the only thing that's affected by this. And then we're going to say pos.x. We're going to do plus equal. I'll explain all this stuff to you. Just wait for a minute while I type it in. Speed. So pos.x or pos period x plus equals speed times time dot delta time. Okay. And then the third line is going to be transform dot position equal POS. All right. All right. So there's a little bit of math here. I should ideally whiteboard this out, but I'm going to put little comments at the end of each line. So what this is going to do, it's going to create a variable, and it's going to capture the current position of the apple tree. Current position. Right? And then we're going to update the position of the X value, which is horizontal, right? So the horizontal value. So the X value, we're going to update that based on the current speed, how fast it's going. And then time delta time is a way that the computer basically keeps track of time. I'll leave it at that. There's a little bit more of a description of it in the book. But basically, we're going to make sure that that time can be consistent with the rest of the motion in our game and consistent with the timing of the computer itself, how many frames per second are going by. It's all very complicated, but by adding delta time means the change in time. So we're going to multiply the speed by the change in time. And then we're going to update the position X from its first value to the new value. So there's current position, and then the change in time multiplied by the speed. So where do we get the speed from? Yeah, the speed is up here. The speed is essentially 1 frame per second, right? So one floating point. So the speed is a constant of 1 right now. If we want things to go faster, we add more to that. If we want things to go slower, we make it slower by slowing it down. We can see how that goes too. And the next thing I want to do is come back over to here, and then I'm going to go into my third line, and the position, that POS value, I'm going to take that position, becomes the new location of the tree. Okay? So, how should I do this? Oh, I think I should just save it and show you, right? Because then we can break it down on the other side of it. All right. So I've updated the script, right? I've added a few things. I look at apple tree. I have the prefab. I have I have all the variables here. When I hit play, watch what happens. All right. Now it's floating. Check this out. Look at it go. Look at it go. It's moving. It's updating, right? So every frame, as it goes by, we're taking the current X value, the current position, and then we're updating it by the speed times the change in time, and then we're going to redisplay it, right? So, so if we let it keep floating, it's just going to float all the way off the screen, and it's going to keep on going. So we need to set a boundary for it, and that's kind of the next step. But for now, what you could do is come over to here, and you could play around with at least the speed. You want to make it go faster? Let's see what happens if we increase the speed to 5. And hit play. And it waits a second, and then there it goes. It's going faster. That's lovely. All right. If we set the speed to 50, we can expect it to zip right off the screen as fast as it can possibly go. And there it goes. It's gone. But, you know, it's not gone. It just keeps going in the distance. So I'm going to reset this to 1, and we'll leave it at that for now. All right. So hopefully this is helping you to get a visual sense of how things are going. And there are a couple of other little things. And he wants us to set the speed to 10 in the inspector here. And he has a bit more of an explanation of delta time as well. But I'm going to go ahead and just to make sure that everything is consistent, I'm going to set the speed to 10 on this guy. All right. So it's 10 meters per second if you're really wondering what it is. It's a metric system in Unity, so it should be good to go. This chapter also explains delta time. I'm not going to belabor this in the video, but it basically helps you to match the frame rate of the display that you're on. So that can be really, really helpful to understand. One of the other things I want to mention, though, is in the code itself, there's this little guy. This is an operator, and you're going to learn about these operators in your Visual Basic stuff. Did I say Visual Basic? Oh my God. Your C# tutorials. In your C# tutorials, you're going to learn about the position, or the plus equal stuff. But basically, it takes the current value of the variable and it adds what's on the right side of that operator to the current variable. So if I were to write this in a freehand, if I was to say 1 plus 1 equals 2, right? Like we know that math checks out, right? If I say 1, let's say I'm using x as a value. Now I'm going to store 1 in x, okay? So now if I say x equals x, that would be 1 equals 1. If I add, why does it keep doing that? If I add 1 to this, right, x equals x plus 1. In math, this doesn't make sense at all. You can never do x equals x plus 1. You just simply can't. It's not a valid equation. It's not going to work, right? So it's not an equation. Not an equation. You got me? It's not an equation. What we really want to see is that now x ends up, I don't know, man, that's just killing me. So I should use a different variable name. X equal is 2 now, right? So if I do, this is all very confusing. I'm really trying to think like you all, and I think some of the stuff that's happening on the screen is really weird. So I'm gonna go over this once more. regular simple mathematics, 1 plus 1 equals 2. We understand that, right? Okay. So let's say we're going to use x to store 1. So x is going to be our container for that, right? If we are storing something in x, then what we're essentially doing, if we want to add 1 to it, we're going to take the current value of x, which is 1, and we're going to add 1 to it, and then we're going to store it back into x. So now x becomes 2, all right? And so we're going to increment our numbers that way, all right? So x is probably not a great example to use, so let's go a little bit further, and I'm going to say speed, right? And I'm just using this as a notepad. So speed equals the current speed times 2, right? We're going to multiply the current speed times 2. It's going to accelerate things by a factor of 2, right? So now speed is actually holding, let's say we define speed as 1, which we did above, right? So if speed is 1, we multiply that by 2 and then put it back into speed, then speed is going to be 2, right? So at least temporarily, speed is going to be 2. And then if we multiply speed equals speed times 2 again, so then speed is going to be 4, right? So we can use the same variable over and over again and increment the speed value as we go along. This is not an ideal, this is not what's happening above, but I want you to get a sense for what we're doing here. With that shorthand, what we're doing is just saying speed is plus equal to 2. And all this shorthand is doing is saying, all right, take what's currently stored as the speed, and we're going to add another 2 to that, and then make it equal to the current speed. Or we're going to store it back into that variable for speed. All right. So that may have felt a little bit like ham-handed, and I agree with you. I'm not exactly sure that I understood what I was saying just there. But keep this in mind. When we have a variable, we can always manipulate that variable and then keep the changes to that variable inside its own variable. And so that's really what's happening here with this plus equal. We have a position, right? And then the current position of x, so we're at 0, the tree's at 0 when it first starts out. And then we're going to take the equation 1 times time delta time, and then we're going to make that the new position. So then we're going to move it over 1, right? And then we're going to update the screen. And then the next time through, we're going to update it 1, and then we're going to update the screen, and update it 1, update the screen, update 1, update screen, update 1, update screen, right? So we're going to keep going in this pattern, and that plus equal operator allows us to do that, right? Actually, all 3 of these lines in conjunction allows us to do that. Whew. Long-winded discussion. Basic point is, as we're working with this code, you're going to have a lot of these little bits in here that are going to kind of defy explanation at first. So let's just kind of accept what's happening here, and then we'll work with we'll work out the explanations a little bit later. All right. So now the second bit of this is to have the tree change direction. And so we want it to change whenever it hits the left and right edge value, which is a variable. We can adjust that as we go. So here you have the basic movement, and then under changing direction, this is the next bit of the script. And so I'm going to take my Visual Studio, and this is now tree movement, and we're going to do changing directions here. All right, and in here, I'm going to just follow along with this code as written. Let me rearrange my screen so I can see things both at the same time. All right, and we're going to use an if-else logic here. So if something is either true or false here, right? We have some logic that's going to happen. and then we have an else, if, and then something else that's going to equate to true or false. And we have a second block of logic there. Okay. So I'm just putting in this true and false as placeholders now. The if else structure it's essentially it's evaluating true or false statements within the parentheses. If something's true, then it's going to do the first thing. If it's not true, then it looks for an else statement, and if the else statement is there, it's going to do that thing. If the conditions are met in the other section. Again, in your C# tutorials, you'll get a better sense for this as well. All right. So we're going to do here, if position X is less than the negative of left and right edge. Okay. And note that he has his little squigglies after that, and I have them down here. For consistency's sake, what I'm going to do is bring those up so that we're consistent with what's available in the book. All it is about consistency. We want to make sure that what we're doing is absolutely consistent. So in my else if, I'm going to do pos.x. pos.x is greater than left and right edge. Okay. So now this is going to end up being a fairly common pattern that you'll see in game programming. It's basically checking to see if the edges are there, and then changing the direction of the object whenever it hits the edges. This is Pong, right? This is Pong. This is any tennis game, any screensaver uses this logic too. It's just bouncing off the edges of the screen. We check to see where the edges of the screen are, and then we have our object bounce off it. So speed is going to help our object to move. All right. So what we're going to do is basically set up a little switch here that says if something is moving to the left, right? I should go. Let me go back to the Unity screen. So when I hit play, right, my object is moving towards the right. It's moving in positive space right now, right? So we're adding. When we hit the edge of the screen, we're going to want to subtract. We're going to want to go negative. So all we want to do is flip from positive to negative. And that's what we're coding for in this next little bit. All right, so here, if position X is less than the negative left and right edge, then we're going to flip it to the right. So this if is going to be, are we at the leftmost side? Right. So we're asking this question: Are we at the left side of this? And if we are, then we're going to flip the code in the opposite direction. All right. So here's what I'm going to do. I'm going to put in the negative case. So position X is greater than left and right edge. All right. I'm going to put in speed equals negative math and abs. So it's absolute speed. So it's the absolute value of the speed. All right. So see this negative? It's going to make it a negative version of this. We're basically multiplying it by -1. Right. So bear with me for a second. I did things a little bit backwards, but I want to see how this works. So I hit play, and I'm moving to the left, and there it goes. See, it bounced, right? But then on the other side, it just keeps on going by for forever and ever and ever. And there it goes. It's just floating away. You see it right there. All right, it's gone. All right, so back here, we have just as an update, our speed is 10, left and right edge is 20. right? And we're working with the left and right edge object item here, right? So I'm going to go back in here, and this is answering the question, are we at the rightmost side? And obviously it was true, because then it flipped and we had speed become negative math of abs speed. But let me just double check to make sure that I'm writing the right code. So this is at position X is less than the leftmost side. This would be negative 20, right? So if position X is less than negative 20, then we're going to flip this to move in a positive direction. Else if position X is greater than the left and right edge, which means it's a positive 20, if it's greater than positive 20, we're going to switch it back, and it's going to go the opposite direction. All right. So when I hit play, we're picking up the code. Boom. And then there it goes. You notice too, like as we're watching it rendered, like the light is going to be bouncing off it. The 3D sort of stuff is all working here and everything. So this is great. Look, I don't want you to feel like you need to know exactly what happened with the code. What I need you to be confident in is that you have been able to successfully write a little bit of code and have essentially a Pong situation happening on your screen. So this is like you've unlocked Atari level graphics at this point. And so you should feel very proud that you can make it out of the 80s knowing how to code a computer. We're going to move into the 90s soon. So get ready. All right, so I'm kind of thrilled with how this is going, to be honest with you. We're in this position where we have a tree that's moving back and forth, left and right, and it's stopping and it's bouncing back and forth. And so if you're having problems, let me know. Tell me what's going on. But the code that you should have in there thus far is going to look like this. You have all of your variable declarations at the top. You have your start, which we didn't put anything in here yet, where we haven't set up anything yet. And then under update, we are moving the tree and changing directions. And those are our two big goals for this part. So I'm going to hit stop to try and keep the videos a little bit short. But now we have a moving apple tree, and we'll move on to the next step in the next video.